Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 2 Structural Analysis, Questions and Answer. 1. Explain moment distribution method, Hardy-Cross method. This method is first introduced by Professor Hardy-Cross in 1932. It is widely used for the analysis of indeterminate structures. It uses an iterative technique. The method employs a few basic concepts and a few specialized terms such as fixed end moments, relative stiffness, carryover, distribution factor. In this method, all the members of the structure are first assumed to be fixed in position and fixed end moments due to external loads are obtained. 2. Define distribution factor. When several members meet at a joint and a moment is applied at the joint to produce rotation without translation of the members, the moment is distributed among all the members meeting at that joint proportionate to their stiffness. Equals H. If there are 3 members, equals 1/1 plus 2 plus 3, 2/1 plus 2 plus 3, 3/1 plus 2 plus 3. 3. Define carryover factor. A moment applied at the hinged end B carries over to the fixed end A, a moment equal to half the amount of applied moment and of the same rotational sense. C.O equals 0.5. 4. What is the difference between absolute and relative stiffness? Absolute stiffness is represented in terms of E, I and L, such as for EIL. Relative stiffness is represented in terms of I and L, omitting the constant E. Relative stiffness is the ratio of stiffness to 2 or more members at a joint. 5. Define stiffness factor. It is the moment required to rotate the end while acting on it through a unit rotation, without translation of the far end being. Equals 3. Equals 4. Where E equals Young's modulus of the beam material, I equals moment of inertia of the beam, L equals beam span length. 6. In a member AB, if a moment of -10 kN is applied at A, what is the moment carried over to B? Carryover moment equals half of the applied moment, therefore, carryover moment to B equals 10/2 equals 5 kN. 7. Define carryover moment. It is defined as the moment induced at the fixed end of the beam by the action of a moment applied at the other end, which is hinged. Carryover moment is the same nature of the applied moment. 8. What is the sum of distribution factors at a joint? Sum of distribution factors at a joint equals 1. 9. What is the moment at a hinged end of a simple beam? Moment at the hinged end of a simple beam is 0. A rigid frame is having totally 10 joints including support joints. Out of slope deflection and moment distribution methods, which method would you prefer for analysis? Why? Moment distribution method is preferable. If we use slope deflection method, there would be 10, or more, unknown displacements and an equal number of equilibrium equations. In addition, there would be 2 unknown support moments per span and the same number of slope deflection equations. Solving them is difficult. What are the limitations of moment distribution method? This method is eminently suited to analyze continuous beams including non-prismatic members, but it presents some difficulties when applied to rigid frames, especially when frames are subjected to side sway. Unsymmetrical frames have to be analyzed more than once to obtain FM, fixed moments, in the structures. This method cannot be applied to structures with intermediate hinges. Brief about Kani's method of analysis. Kani's method of analyzing indeterminate structures, particularly building frames, was developed in Germany in the year 1947 by Drive Gasper Kani. Like moment distribution, it is a method of solving slope deflection equations by an iterative method. Hence, this will fall under the category of stiffness method, wherein the level of difficulty would be decided by the degrees of freedom, and not the degree of redundancy. What are the limitations of Kani's method? Gasper Kani of Germany gave another distribution procedure in which, instead of distributing entire moment in successive steps, only the rotation contributions are distributed. Basic unknown like displacements which are not found directly. What are the advantages of Kani's method? Hardy-Cross method distributed only the unbalanced moments at joints, whereas Kani's method distributes the total joint moment at any stage of iteration. The more significant feature of Kani's method is that the process is self-corrective. Any error at any stage of iteration is corrected in subsequent steps. Framed structures are rarely symmetric and subjected to side sway, hence Kani's method is best and much simpler than other methods like moment distribution method and slope displacement method. State Miller-Breslau principle. Miller-Breslau principle states that, if we want to sketch the influence line for any force quantity like thrust, shear, reaction, support moment, or bending moment in a structure, we remove from the structure the resistant to that force quantity. We apply on the remaining structure a unit displacement corresponding to that force quantity. The resulting displacements in the structure are the influence line ordinates sought. Define rotation factor. Rotation factor in Kani's method is akin to distribution factor in moment distribution method. Actually, equals 0.5 times. Define displacement factor. Is the displacement factor for each column similar to we adopted earlier for rotation factor? Actually equals 1.5 and is applicable to column only. What are the basic principles of compatibility? Compatibility is defined as the continuity condition on the displacements of the structure after external loads are applied to the structure. Define Kani's method and how it is better than moment distribution method. Kani's method is similar to the moment distribution method in that both these methods use Gauss-Seidel iteration procedure to solve the slope deflection equations, without explicitly writing them down. However, the difference between Kani's method and the moment distribution method is that Kani's method iterates the member end moments themselves rather than iterating their increment. Kani's method essentially consists of a single simple numerical operation performed repeatedly at the joints of a structure in a chosen sequence. Write the procedure for Kani's method. While solving structures by this method, the following steps may be kept in mind. Compute all fixed end moments. Compute and tabulate all rotation factors for all joints that would have rotation. Fixed ends will not have rotation factors, nor rotation contributions either to the same fixed end or to the opposite end. Extreme simply supported ends will initially get a fixed end moment. Iterative process can be formed. What is an arch? Explain. An arch is defined as a curved girder, having convexity upwards and supported at its ends. The supports must effectively arrest displacements in the vertical and horizontal directions, only then there will be arch action. What are the various types of hinges in arch? Or, what are the types of arches according to the support conditions? 3 hinged arch, 2 hinged arch, single hinged arch, fixed or hinge-less arch. State the general cable theorem. The general cable theorem helps us determine the shape of a cable supported at two ends when it is acted upon by vertical forces. It can be stated as: at any point on a cable acted upon by vertical loads, the product of the horizontal component of cable tension and the vertical distance from that point to the cable cord equals the moment this would occur at that section if the loads carried by the cable were acting on an simply supported beam of the same span as that of the cable. Define horizontal thrust. In a 3-hinged arch, the force is calculated by equating the bending moment at the central hinge to 0. The horizontal thrust reduces the beam bending moment called X. H equals. What are the types of arches according to their shapes? Parabolic arch, elliptical arch, polygonal arch, curved arch. What is a linear arch? If an arch is to take loads, say W1, W2, and W3 in a vector diagram and funicular polygon are plotted as shown in figure, the funicular polygon is known as the linear arch or theoretical arch. The polar distance OT represents the horizontal thrust. The links AC, CD, DA and EB will be under compression and there will be no bending moment. If an arch of this shape ACDEB is provided, there will be no bending moment. For a given set of vertical loads W1, W2, etc., we can have any number of linear arches depending on where we chose O or how much horizontal thrust, OT, we choose to introduce. 27. Why stiffening girders are necessary in the suspension bridges? Stiffening girders enable the suspension bridge decks to remain fairly level. Whatever be the live load on the deck slab, the stiffening girders will convert and transmit the load on the deck slab as a uniformly distributed load and thereby help the cable retain the parabolic shape during the passage of loads. The dead load of the girders, which is a UDL, is directly transmitted to the cables and is taken up entirely by the tension in the cables. Thus the uniformly distributed dead load will not cause any shear force or bending moment in the stiffening girder. The stiffening girders will have to resist the shear force and bending moment due to live loads. State the Eddy's theorem for an arch. Eddy's theorem states that the bending moment at any section of an arch is equal to the vertical intercept between the linear arch and the center line of the actual arch. Equals 2, 3 times. What is the difference between the basic action of an arch and suspension cable? An arch is essentially a compression member which can also take bending moments and shears. Bending moments and shears will be absent if the arch is parabolic and the loading uniformly distributed. A cable can take only tension. A suspension bridge will therefore have a cable and a stiffening girder. The girder will take the bending moment and shears in the bridge and the cable, only tension. Because of the thrusts in the cables and arches, the bending moments are considerably reduced. If the load on the girder is uniform, the bridge will have only cable tension and no bending moment on the girder. Under what conditions will the bending moment in an arch be zero throughout? The bending moment in an arch throughout the span will be zero, if the arch is parabolic. The arch carries UDL throughout the span. Indicate the positions of a moving point load for maximum negative and positive bending moments in a 3-hinged arch. Considering a 3-hinged parabolic arch of span L and subjected to a moving point load W, the position of the point load for maximum negative bending moment is 0.25 L from end supports. Maximum positive bending moment is 0.211 L from end supports. 32. Distinguish between 2-hinged and 3-hinged arches. 2-hinged arches. 3-hinged arches. Statically indeterminate to first degree. Statically determinate. Might develop temperature stresses. Increase in temperature causes increase in central rise. No stresses. Structurally more efficient. Easy to analysis. But in construction, the central hinge may involve additional expenditure. Will develop stresses due to sinking of supports. Since this is determinate, no stresses due to support sinking. Explain rib shortening in the case of arches. In a 2-hinged arch, the normal thrust, which is a compressive force along the axis of the arch, will shorten the rib of the arch. This in turn will release part of the horizontal thrust. Normally, this effect is not considered in the analysis, in the case of two hinged arches. Depending upon the importance of the work, we can either take into account or omit the effect of rib shortening. This will be done by considering, or omitting, strain energy due to axial compression along with the strain energy due to bending in evaluating H. What is a catenary? Catenary is the shape taken up by a cable or rope freely suspended between two supports and under its own self-weight. Mention the different types of cable structures. Cable over a guide pulley. Cable over acetyl 36. Briefly explain cable over a guide pulley. Cable over a guide pulley has the following properties. Tension in the suspension cable equals tension in the anchor cable. The supporting tower will be subjected to vertical pressure and bending due to net horizontal cable tension. Briefly explain cable over saddle. Cable over saddle has the following properties. Horizontal component of tension in the cable equals horizontal component of tension in the anchor cable. The supporting tower will be subjected to only vertical pressure due to cable tension. What are the main functions of stiffening girder in suspension bridges? They help in keeping the cables in shape. They resist part of the shear force and bending moment due to live loads. Give some examples of beams curved in plan. Curved beams are found in the following structures. Beams in the bridge negotiating a curve. Ring beams supporting a water tank. Beams supporting corner lintels. Beams in ramps. Define tension coefficient of a truss member. The tension coefficient for a member of a truss is defined as the pull or tension in the member divided by its length, i.e., the force in the member per unit length. What are cables made of? Cables can be of mild steel, high-strength steel, stainless steel, or polyester fibers. Structural cables are made of a series of small strands twisted or bound together to form a much larger cable. Steel cables are either spiral strand, where circular rods are twisted together, or locked coil strand, where individual interlocking steel strands form the cable, often with a spiral strand core. Spiral strand is slightly weaker than locked coil strand. Steel spiral strand cables have a Young's modulus, EOF 150 plus or minus 10 kN/mm superscript 2 and come in sizes from 3 to 90 mm diameter. Spiral strand suffers from construction stretch, where the strands compact when the cable is loaded. Where do you get the rolling loads in practice? Shifting of load positions is common enough in buildings, but they are more pronounced in bridges and in gantry girders over which vehicles keep rolling. List the categories of rolling loads on beams. Single concentrated load. UDL longer than the beam span. UDL shorter than the beam span. 2 wheel axles separated by a fixed distance. Multiple wheel axles, train of loads. What are the objectives of study on rolling loads? To find the load position and values of maximum shear force and bending moment at adjovan section due to adjovan system of rolling loads. To find the location and values of the absolute maximum shear force and bending moment that may occur on the span due to the given system of rolling loads. To find the equivalent UDL due to a given system of rolling loads to make the designer's work simple. Name the type of rolling loads for which the absolute bending moment occurs at the mid-span of a beam. Single concentrated load, UDL longer than the span, UDL shorter than the span also when the resultant of several concentrated loads crossing a span coincides with a concentrated load, then also the maximum bending moment occurs at the center of the span. What is the absolute maximum bending moment due to a UDL longer than the span of a simply supported beam? When a simply supported beam is subjected to a moving UDL longer than the span, the absolute maximum bending moment occurs when the whole span is loaded. Max equals 2/8. State the location of a maximum shear force in a simple beam with any kind of loading. In a simple beam with any kind of load, the maximum positive shear force occurs at the left-hand support and maximum negative shear force occurs at right-hand support. What is meant by absolute maximum bending moment in a beam? When a given load system moves from one end to the other end of a girder, depending upon the position of the load, there will be a maximum bending moment for every section. The maximum of these bending moments will usually occur near or at the mid-span. The maximum of maximum bending moments is called the absolute maximum bending moment. What is meant by influence lines? An influence line is a graph showing, for any given frame or truss, the variation of any force or displacement quantity, such as shear force, bending moment, tension, deflection, for all positions of a moving unit load as it crosses the structure from one end to the other. An influence line for any given point or section of structure is a curve whose ordinates represent to scale the variation of a function, such as shear force, bending moment, deflection, etc. At the point or section, as the unit load moves across the structure. ILD for determinate beam is linear and for indeterminate structure is curvilinear. What are the uses of influence diagrams? Influence lines are very useful in the quick determination of reactions, shear force, bending moment, or similar functions at a given section under any given system of moving loads and. Influence lines are useful in determining the load position to cause maximum value of adjovan function in a structure on which load positions can vary. Thank you for watching. Also see the Part 1.
Thank you for watching. Please subscribe to the channel and press the bell icon.